Hello, my name is Caleb Bradley. This is Lab 3 of FPGA design using VHDL. And what I have before you is the Max 10 device using, it is currently configured to be a multiplexer. We have, in total, we're using all of our switches. So from switch 9 to switch 0, these are all of our inputs. And we have our outputs for the multiplexer. Our switch 9 through switch 6, they're currently off right now, but if I do this, and I also have an output for a hex display, which is the hex digit equivalent to what we have out here. So how this works is we have our enable input, which is switch 9. Just focus, please. Oh yeah, we have our enable input, which is switch 9. This controls the circuit. It is active low, so if I were to switch it high, the entire circuit would not. It doesn't matter what I do to any of the switches, there will be no response from the outputs. So I'll just put everything low for right now. My switch 8 is the switch that determines whether we use the top 4 inputs for the first part of our multiplexer, because it is a 4. Well, we'll use for if we were to switch it high, and if our enable was low, but since this is active low, it would activate our top 4 switches here were our switches 7 through 4. This is our input A. We have 4 of them because this is a 4-bit input code. So if switch 8 is high, because that's our switch, if we switch it to low, then it will activate the second half of our multiplexer, which is our input 0, and that will go to the output. So for right now, I'm going to leave it low, and I have our output. Our output will get whichever set of inputs that the switch points to will point to this output, and it will also be represented in our hex digit through using this hex display. So I'm going to show you what happens when it is low, when both the enable and the switch is low. So here we go, we turn on the LED, and that's R1. You can see, follow along with that. And there's 2. And then, let's see, 3. Then I'll make these both low. 4, 5, 6. As you see, they're lining up with our output here and our output here. Then we go 7. Then I go down here. I go 8. And past this point is when we start getting to, 9. Now, actually past this point, this is where I had to do some extra interesting stuff to make our output display in the hex. So past here, this would be 10, but here it's A, since this is a hex. This is written in hex. Then this is, well, first let me put that back on. This is B, which is 11. Then we go down. Then we go down and we go to C, which is 12. Then D, which is 13. Then we go to E, which is 14. And finally, F, which is 15. So if I try to manipulate any of the other ones from the other set, since our switch is active low, none of these will matter. So I can turn on all of them and they won't influence the output. But if I were to switch low, if I were to switch this switch high, then it'll switch and it'll start displaying the output for the first set of our 4-code input. So by this logic, I'm going to leave all of these switches high, but I'm going to start manipulating switches 7 through 4. So you can see that it also works as intended. So all of our switches from 3 to 0, which is part of our input 0 code, they're high right now, but we're displaying a 0 and our LEDs are off. That is because we are just directly porting the input from our input 1, which is 7 through 4, directly to our output. So since all these switches are low, that means our output is low. So if I can run through it again, so you have 1, 2, 3, we jump down and we go 4, 5, 6, and it doesn't matter if I were to start manipulating this halfway through, they don't have any effect on the output. Then 7, 8, 9, we go to our hex versions of 10 and above. This is 10, 11, and we go 12, 13, 14, and finally 15. So if I were to switch the switch down, because our current set of inputs is 15, but our other set is 0. So if I were to switch this switch, which determines whether we are pointing towards the high or to input 1 or input 0, then it will just switch over to this, and if we were to switch it back, it'll go to the first set. So when it's low, it targets these 4 switches, and when it's high, it targets these. So, and it doesn't matter if my enable is high, since this is an active low input. If my enable is high, right, then none of my inputs go to the output, because it doesn't matter. It doesn't matter if I switch the switch to try to get to the other inputs. If I change any of these, since it's active low, and when it's high, it will not react. There will be no change in the circuit. And this concludes Lab 3 of FPGA design using VHDL.